Okay, so I did image height, and then I want to do like HO as object height. And then we have DO as object distance. And then we have DI as image distance. And then we have focal length. And capital M is magnification. How big something is made by light passing through a lens. So remember that M is HI over HO equals negative DI over DO. All right. And then it says, talks about Michaela takes a converging lens out of ice that will enable her to concentrate light from the sun to start a fire. When she holds the lens 1 meter from a snow-covered wall, an image of her 5-meter distant igloo is projected onto the snow. What is the focal length of the ice lens? So 1 over DI plus 1 over DO equals 1 over F. Well, her DI is 5 meters. And her DO is 1 meter. So that's going to be 1 over 5 plus 5 over 5 equals 1 over F. So that's 6 over 5 equals 1 over F, but I don't want 1 over F, I want F over 1. So that's 5 over 6, which is 0.83 for the focal length. Okay. Then we have number 2. Number 2 says, Sadie looks at her friend's face through a diverging lens. That's the one that looks like that. Is the image real or virtual? They're always virtual with that kind of a lens. If our friend's face is 50 centimeters from the lens, that forms an image of 20 centimeters. What is the focal length? So, not well written. But what I should say is that the focal length is equal to 1 over DI plus 1 over DO. And the image is formed at 20 centimeters. So 1 over 20 plus 1 over 50. So the common denominator would be 100. Now, that's 5 over 100 plus 2 over 100. I got to be careful because my image distance needs to be negative right there, so that was my bad. Because it's a virtual image, so the image distance is always negative. So that's negative 5 over 100 plus 2 over 100 is negative 3 over 100 equals 1 over F. So F is 100 over negative 3 equals negative 33 1/3. Okay? And then finally, the last one. Benjamin makes his girlfriend a romantic candlelight dinner. So this is what you're given for your diagram. And you have this ray coming in right here at 44 degrees. And then it bends kind of down that way at 30 degrees. So this is the air. This is the gelatin of the jelly bean. And they want to know what is the index of refraction of the jelly bean. So N1 sine theta 1 equals N2 sine theta 2. So it goes from air, which is 1.00, times the sine of 44 degrees, is equal to N2 times the sine of 33 degrees. So N2 is 1.39. I'm sorry, that's 30 degrees right there. My bad. 30 degrees. So 1.39 is the index of refraction of the jelly bean. All right, please study.